In this video, we'll be solving a problem relating to circles, sectors, and arcs in geometry. Here's the problem statement. In the diagram, AB and AD are the two tangent lines of circle O that go through A. We know angle C equals 4 times angle A. Find the degree measure of arc BCD. So AB and AD are the two tangent lines, which means that they touch the circle O here at exactly one point. We've got the point B here and the point D. So there's actually a rule we can leverage here that may not necessarily be important, but it's a good thing to point out and to keep in mind if you were to encounter a future problem like this, is that AB and AD must be equal in length because they're the two tangent lines of the same circle. So they must be the same length. Okay, we'll see if we actually end up using that here to solve this problem. So, we want to know the degree measure of arc BCD. So it's going the long way around the circle, starting at B, then all the way around, going through C, which C should really be more like here, then ending over here at D. So it goes all the way around, passing through C, B, C, D, then it stops right there. Okay, and they want to know the degree measure of that arc, which essentially means what they're asking for is, you can think about it as being the central angle, the measure of the central angle including that arc. And we also must remember that the measure of the circumference of the circle, the entire thing, is 360 degrees. So it's going to have to be less than that. Okay, so let's first label the center of this circle as O, as they said here. So here's the center, and it's usually helpful, a really good technique for solving these sorts of circle problems is to connect lines across the circle. Now we have a center here, and it would be really helpful to connect B to O and D to O, because that helps us maybe discern some additional relationships, get some triangles or quadrilaterals maybe even. So let's go ahead and connect OB. So we have line OB, then line OD. Okay, so as you can see here, we have some new shapes. It looks like we have a four-sided figure, a quadrilateral here, BODA. Here we have side 1, side 2, side 3, these two long ones here, and side 4 to make it extra clear there. Okay, so we have a quadrilateral, and in a quadrilateral, we know that the angles must sum to 360 degrees. We also know that this angle must be 90 degrees because the intersection angle of a tangent line, in this case, AB, I don't know why this won't zoom out, the intersection of a tangent line and the tangent point to the radius of the circle, which is OB here, is always going to be 90 degrees. It's always going to be a right angle from the radius to the tangent line. Same thing over here because the other line, AD, is also a tangent line. Okay, so we know two angles of this quadrilateral already that give us 180 degrees. Now we have this central angle, this large one here, and we've got this small one. Now they tell us in the problem statement that angle C, which is all the way out here, is 4 times angle A in there. Now, you could note that angle C is inscribed in angle BOD, the huge one. And an inscribed angle basically means it's found in that same arc, where that same arc is BD here. You see this part going through. Yes, they're both part of the same arc. And there's a property of inscribed angles that says the central angle is going to be twice the measure of the inscribed angle. Now, we already know, obviously, the central angle is BOD because it's right there in the center of the circle. So we know angle BOD, I'm going to write this down here, angle BOD must be twice the measure of angle BCD, the smaller one in here, the green one, BCD. It'll be twice the measure of BCD. Okay, so, and they don't tell us any numbers here, but what we can do is we can set up an equation. And we can use the variable x here, we can set x to the thing we're trying to find, or a step towards the thing we're trying to find. So let's set x to be angle A over here because that's very crucial. They tell us C is 4 times angle A in the problem statement. So if x is our angle A, or BAD to be clear, we're going to have x and then plus 8x, because the 8x refers to angle BOD, and then plus 4x to refer to BCD, because 4x is half of 8x, as we proved with the inscribed angles. Then finally, plus our two 90-degree angles, as we saw there for the tangent lines. And all of that must equal 360 degrees. Okay, so we've got a total of 9x. Actually, no, we can scratch 4x, disregard this. Empty space. Okay, so what we have is 9x plus 180 equals 360. Simple solving an equation here, we subtract 180 from both sides, we get 9x equals 180. And finally, we just divide both sides by 9 to get x equals 20. So we know the degree measure of angle A here must be 20 degrees. Okay, so now, they tell us angle C is 4 times angle A, which means angle C in here is going to be 4 times 20, which is 80 degrees. Now we're a step closer to solving this problem now, because you know what? We proved earlier that BOD is twice angle BCD because the inscribed angle theorem. So we know angle BOD must be 160 degrees. That's twice 80. Okay, and finally, we can just solve the problem from here, because they want to know arc BCD, and we already know arc BD now because of this central angle. Remember, the measure of an arc is the same as the measure of its central angle. So measure of arc BD is going to be, we're going to use the arc symbol on top of there, is 160 degrees. And now all we have to do to find the measure of arc BCD is do 360 minus 160 to give us simply 200 degrees. And there's our answer. We have successfully found the measure of the major arc BCD going the long way around the circle, using the inscribed angle theorem and other useful properties of circles.